Hi, today I'm going to discuss about work and energy. So what do we mean by work and energy? So when we say work, we sometimes refer this as a certain job or a certain people who's exerting their forces under certain works. And when we say energy, during heavy work or during exercise, sometimes we say we lose energy, meaning to say we are tired. But in physics, these words are very specific. When we say work, it is defined by an energy being transferred by a force. And when we say energy, it is the ability or the capacity to do work. Now, work is equal to the magnitude of applied force times the displacement of an object. So we come up with the formula W is equal to Fd, or work is equal to the force being exerted times d, or the displacement. Now, if I am going to push an object, say for example this kind of object, and I'm going to push it, and I exert, say for example, a 10 Newton force. So I exert a force of 10 Newton into a distance of 0.5 meter. So for example, the distance na na-cover natin is 0.5 meter. So now, the work here is equal to the energy that I applied. Newton meter is equivalent to another SI unit called joules. So our answer in this sample problem is 5 joules.
Work can only be done when displacement occurs, so no displacement means zero work. In addition, only the component of the applied force parallel to the displacement counts toward work. For example, is pushing an apple parallel to the floor. All its effort contribute to work done on the apple. But if you're pushing the box on downward angle, only X component contribute to work while Y component does not. In this scenario, we'll use the formula work is equal to force times distance times cosine theta, where theta is the angle from the horizontal. If theta is 0, the equation becomes W is equal to Fd. This is because the cosine theta will be equal to 1. If the theta is in 90 degrees, the cosine theta will be 0, meaning no work is done on the object. Work is a scalar and it can be positive or negative. Work is positive if the applied forces is in the same direction as the object in motion. Work is negative if the applied force is in the direction opposite of the displacement.
Ngayon, pag sinabi natin energy, this is merely a property of a system that can be transferred to another system by means of work. And there are different types of energy. So, nandyan yung chemical energy, elastic energy, and the two types that is often being discussed in physics is the potential and kinetic energy. Okay? So, pag sinabi natin potential energy, these are the energy that is being stored. And pag sinabi naman natin kinetic energy, these are the energy that is in motion.
An example of potential energy is a rubber band twisted up and held in place. Once the rubber band is released, it unwinds quickly as kinetic energy.
Energy is summarized in the work energy theorem. Okay. This states that when work is done on an object, there will be a change in kinetic energy, which is shown in this diagram. So, this means that an object in motion can be able to do work on another object. Para mas maintindihan pa natin ang ating topic, let's demonstrate it using our homemade catapult. Okay, so using this, we should be able to show how energy is created, stored, transferred, and converted. Catapult physics is basically the use of stored energy to hurl a projectile without the use of an explosive. The force from my hand is pulling the throwing arm down against the force of elastic band, o yung ating rubber band. This elastic force is caused when the elastic band is stretched. Now, this gives the band plus the throwing arm of the catapult elastic potential energy. When we let go the popsicle stick or the throwing arm, the stored energy is transferred to the object launched in the bottle cap, which then flies through air, meaning transferred kinetic energy is the main reason for throwing the projectile out of the bottle cap. From this, we have converted the potential energy into kinetic energy. With this device, we can also calculate the work done by measuring the mass of an object being hurled and the angle to get the force being exerted as well as the distance by the trajectory. To sum up everything that I have stated, catapult uses elastic energy which is transferred into kinetic energy and retention stored in the rubber bands. With the use of catapult, we're also able to apply the physics formula as well as relationship we have discussed recently. Did you know that catapults back then were used as a very effective weapon during the ancient times? Some are made so large that can disrupt walls of castles, causing great damages.